Problem 15 tells us that a toy manufacturer makes lightweight balls for indoor play. The large basketball uses, and then some information, right? And then the football, then some information. Now what we want to do is, okay, they're telling us to use the simplex method, which of course that's what we would do. Now there's only two variables here. So we could do this by graphing, but it's better to use the simplex because we can use our ZWIG media site. So let's solve this problem, and what we want to do is determine the optimal production schedule so as to maximize profits. Let's start as we always start by introducing variables. So we're going to let X be the number of basketballs to be manufactured and Y be the number of footballs to be manufactured. Now our categories are basketballs and footballs, so I'm going to set those up right here, basketballs, footballs, and then we'll have maybe our totals here. Now, what about the characteristics? The characteristics we put down as our rows. What characteristics do we have? It says a basketball uses our, so what do we have? We have foam, and we have labor, and we have a profit. Okay, and then the same thing for football. Foam, ounces of foam, labor, and profit. So let's put down foam, labor, and profit. I'll separate these off. Now let's read through here. What are we trying to do here? Right at the bottom it says, where is it? Use the simplex method to determine the optimal production schedule so as to maximize profit. Now here's what we know. Let's start filling these things in here. So what do we know for basketballs? That takes 4 ounces of foam, so we can put a 4 here, and then what? 20 minutes of labor, so I'm going to put a 20 down here, and it brings a profit of, where is it? Profit of what? $2.50. Then footballs. Okay, footballs, 3 ounces of foam, 30 minutes of labor, and a profit of $2. So this is going to be 3, 30, and 2. Now what about our totals? How much do we have available? So it says, let's see. What do we have? Okay, here it is. The manufacturer has 48 pounds of foam available. Oh, okay. We need to be careful here. You see what's going on? A little bit tricky, I think. They're giving us ounces, but then they tell us we have pounds. All right, so we need to convert ounces in pounds. So we have, what, 48 pounds. Okay, now 48 pounds of foam is available. So we've got everything in ounces. So I'm going to take this as going to be, we don't have to use it all, so less than or equal to, all right, 48 pounds times 16, right? Because the 16 is 16 ounces per pound. Okay, so 48 pounds times 16, that's the total number of ounces, and that turns out to be 768. Now I'm going to watch out for the same thing for labor. What have we got going for labor? It says, okay, labor is in minutes, but what do we have for labor? We got 120 hours of labor available. So this is going to be 120 hours, so less than or equal to 120 hours, but this is, I want to convert it to minutes. Minutes because all of this is in minutes. So how about multiply it by 60, and that gives us 7,200. So let's write our linear program. So we're going to write this as maximize the profit, which is 2.5 times x, so 250 x's plus 2 y's, subject to. Now this is going to be direct, this is just going to come directly from our table here, right? So this is just going to be 4x plus 3y is less than or equal to 768, and 20x plus 30y less than or equal to 7,200. And of course, x greater than 0, y greater than or equal to 0. So here is our linear program. We're going to use the simplex method to solve this problem, but we're not going to do it by pencil for sure. We're going to use the ZWIG site. Now, there's probably other sites here, but I found this one just to be really convenient. So the ZWIG Media site can be found here. Now, I don't think you can click on this because it's just a picture that I popped in, but you can find it on the syllabus, or if you've used it before, maybe you can bookmark it. But go to the syllabus, you'll find it partway down, click on it, it will take you to this screen right here. So here is our entry field. So in the entry field, I'm going to start typing this program. I've typed in my program, maximize P equals, here's our objective function, subject to, all on one line. I put in the inequalities down here, being careful now that this was, right, this is in ounces, so they gave us pounds, we had to convert, so it was what, 48 times 16. This was in, what was this in? This was labor, this was in hours, so we had to change that to minutes. So we multiplied our 120 hours by 60 minutes to an hour, getting that 7,200. Then, next thing I'm going to do is press the solve key, right? So I'm going to go to the solve key, I'm going to press solve, but I'm ensuring that I've got what? Now, this is on decimal. You don't really have to do decimal. If you want to do fractions, you're just fine. That's good. I've got 6 significant digits, so press solve and let's see what happens. So I press solve and the initial tableau comes up. Then with some row operations, you get a second one, and then you get a third and final tableau. Now, I know it's final because I scrolled down to make sure this is the final tableau. This is the one I want to look at in order to read off my solution. So what do we know about x's? Let's go over here. Now, in x, you've got a 1 and then 0, so we'll get a good value for x. 1x is 24, so I'm going to write that up here. And what about y? Well, you come to the y column, you get a 1 and 0, so we'll get this value for y. 1y is 224. And while we're at it, let's get our other variables. So it looks like S1 and S2, or our u and v. All right, there's no 1 in all zeros, so this has to be a 0, so u is 0. Likewise, v is 0, so let's make that claim. u is 0, v is 0, and p, what do we get for P? That's our profit. So you come to the P column, you have a 1 in all zeros, so a P is 508. So P is 508, and let's interpret all these numbers. So what was X? X was the number of basketballs that we were going to manufacture, so we're going to manufacture 24 of those. Y was the number of footballs we were going to manufacture. We'll make 224 of those. U, that was the amount of foam. So that was going to be the number of unused ounces of foam, and there is none. So we've used all of our foam. Likewise, V, well, V was the number of hours of labor, and there's none left, right? So we've used all the foam, all the labor, giving us a profit, a maximum profit of $508. So let's write a solution. Let's report the answer to the question. We're going to say the profit is maximum at $508 when we manufacture 24 basketballs and 224 footballs.